5-3 is all about radicals. Radicals. Radicals is just another name for square roots. Square roots and other types of roots, well, which we'll learn about later this year. Anyways, first of all, let's kick it old school with some simplifying radicals. I almost put a T in there. Simplifying radicals. Start off with the square root of 12. The square root of 12. Now, there's a couple ways to learn the way to simplify radicals. You could just think of what multiplies to 12, try and come up with perfect squares. I don't like that method. I like to do the tree. And some of you are probably familiar with the tree. What multiplies to 12? What's nice about this method is you don't have to think of perfect squares. You can just think of anything that multiplies to 12. So in this case, 6 and 2. All right? What multiplies to 6? 2 and 3. Now, when you're doing the tree method, you only look at the ends of the tree. So in other words, this 6 doesn't exist anymore. We're looking at 2, 3, and 2. The reason why is because those are the factors of 12. If you multiply these, you'll get back to 12. 2 times 3 is 6, times 2 is 12. Now, in order to get out of radical land, you need a buddy. Can't do it alone. Many have tried, many have perished. So, 2, 3, and 3, has got a buddy? 2's got a buddy. So there's a pair of 2's. Now, they wait till nightfall. They make a break for it. They put the little head with the blanket and the stuff with the pillows, so it looks like they're sleeping, but they go for the wall. And then one of them puts his hands out and they jump over the wall, but sadly, only one of them makes it out. Right now, the other guy that didn't get a buddy, the 3, got left behind inside radical land. He is inside radical land. So, if you get a buddy, only one of you is going to go and make it out, but you can't even attempt it without a buddy, like the 3 here, and he got left behind. So the square root of 12 reduces to 2 root 3. One way that you could use to check your answer is use your calculator. Root 12 is 3-point gross. If you put in 2 times root 3, you should get the same 3-point gross. Moment of silence for our fallen 2. All right, let's do a couple more examples here. Let's do the square root of 48, the square root of 72, the square root of 50, and the square root of 17. Take a moment, press pause, and hook these 4 examples up here. All right, so hopefully you got 48. We'll multiply to 48, 6 and 8, 2 and 3. 8 breaks down to 2 and 4. 4 breaks down to 2 and 2. Buddies. Now, there's a pair of 2's, so a 2 comes out. Here's another pair of 2's, so another 2 comes out, but we're going to multiply them. All right? What got left behind? The 3. Root 3. So 2 times 2 is 4 root 3. Square root of 48 is 4 root 3. 72. 8 and 9. 9 breaks down to 3 and 3. 8 breaks down to, one of the things that you'll figure out about 8 is 8 breaks down to 2 and 4 and everything else. But rather than break down to 4, you'll start finding shortcuts like making 8 2, 2, and 2. Because 2 times 2 times 2 is 8. So, who's got buddies? Pair of 2's, a 2 comes out. Pair of 3's, so a 3 comes out, and a 2 got left behind. So square root of 72 is 6 root 2. Root 50. 50 breaks down to 25 times 2. 25. Now, sometimes, again, you might come up with little tricks. I know that 25 is a perfect square, so rather than branching it off and everything, I just put a square around 25. And I know that the square root of 25 is 5, and a 2 got left behind, 5 root 2. little shorthand. If you come upon a perfect square, just put a square around it, and that way you don't got to branch it off like we did here 9. If we just put a square around 9, we know what 3 comes out. If you like that, use it. If you don't, go ahead and make a branch. Now, some of you have been thinking, Smith, I didn't use 6 and 8. I didn't use 8 and 9. I didn't use 25 and 2. On 50, I used 10 and 5. And 10 breaks down to 2 and 5. And see, I got a totally different answer because a pair of 5s and a 5 comes out, but a 2... Oh, right. Comes out the same way. It doesn't matter which ones you choose. As long as you factor them down correctly, you should always get the correct answer. 17. Nothing multiplies to 17 except for 17 and 1. So this is 17 is a prime number. Since nothing comes out, our final answer is the square root of 17. It doesn't simplify further. All right, so that's simplifying radicals. That should be a review from geometry and algebra 1. There's 2 rules that you may or may not be familiar with. There's 2 rules that will help us out here. And the first one is, if you have root A times root B, that will give you the square root of A times B. All right, let's do a quick example of that one. Quick example here would be 2 root 6 times 8 root 10. Now, what can be multiplied together? Well, we got these regular 2 and regular 8. And then we've got root 6 times root 10. That kind of looks like this. Root A times root B, we can multiply radicals. So, 2 times 8 is 16 times the square root of 60. Are we done? Not quite. You got to simplify 60. If it can simplify, simplify. What multiplies to 60? Well, clearly 6 times 10. That's how we got it, right? Anyways, 6 times 10, 6 breaks down to 2 and 3. 10 breaks down to 2 and 5. So a 2 comes out. There's already a 16 outside here, right? So it would be 32 times the square root of... Now, 3 and 5 both got left behind inside radical land. So it's 32 root 15. Make sure you simplify completely. It's just like a fraction. If you can simplify, you got to simplify. The second rule is the square root of a fraction, A divided by B, reduces to root A divided by root B. So, quick example here. Sometimes it's really easy. Root 25 divided by 49. If you have the square root of a fraction, do the square root of the top divided by the square root of the bottom. Square root of 25 is 5 divided by 7. Look how pretty that is. We got 5 7. The square root of 25 49ths, that's a nightmare. You simplify it to 5 7ths, I understand that. The last one is solving using square roots. Every operation has an inverse, has an enemy that undoes it. For example, x plus 2, what would you do to get rid of 2? You would, x plus 2 is equal to 9, you would subtract 2, right? If you have 2 times x is equal to 9, how do you times 2 it? You divide by 2. If you have x divided by 2, you would multiply by 2. Today what we're going to talk about is, what if you have x squared is equal to 9? Well, how do you unsquare something? What is the enemy of squared? Like we said, the enemy of plus is minus. The enemy of multiply is divide. The enemy of divide is multiply. How do you unsquare something? You square root both sides. Now, the thing is, though, we'll be left with x equals, the square root of 9 is indeed 3. And we should check our answer. 3 squared is 9. Right? However, is there anything else that when we square it equals 9? Some of you might have figured out that negative 3. Negative 3 squared is 9. Negative 3 times negative 3 is 9. So here's the thing. Whenever you use a square root to solve, you have to put a plus or minus. If you use a square root to solve, you have to put a plus or minus. You must put plus or minus by the answer. If you use a square root to solve, you must put a plus or minus by the answer. Wait a second, Smith. Way back at the beginning of the notes, the square root of 12, you didn't put plus or minus 2 root 3. You just said it was 2 root 3. Here's the thing. We're just simplifying here. To make simplifying simple, we're just going to go and do our square root, our trees, and be done with it. It's only when you're solving, when you have to list all possible answers as a solution to an equation, that's when you put a plus or minus. Only when you're solving. All right, now let's do 2 more here. The next one's going to be parentheses x minus 3 quantity squared equals 18. All right, now this one's a little bit different. It's got x minus 3 parentheses, the quantity is squared. We got to get rid of this square root thing, or the squared. So we're going to square root this entire thing first. Square root undoes square, we're left with x minus 3 equals, now the square root of 18 is plus or minus, 18 reduces to, what multiplies at 18? 9 and 2, 3 and 3, so plus or minus 3 root 2. Then you get x by itself. Add 3 to both sides, so you get x is 3 plus or minus 3 root 2. You give that whole answer. This is exact. Now, there's actually 2 solutions here, right? 3 plus 3 root 2 and 3 minus 3 root 2. One more for you. The last one, we'll do 2x squared plus 1 equals 17. So, first thing you would do, remember, solving is the order of operations backwards. Remember PEMDAS? Get rid of addition and subtraction first, so you'd be left with 2x squared equals 16. So we got rid of addition and subtraction. Now we get rid of multiplication and division. X squared equals 8. Then you get rid of exponents. So square root both sides. And you get x equals, square root of 8 is plus or minus 2 root 2. Plus or minus 2 root 2. Make a tree with 8 if you need. Wait a second, Smith, here there's minus here. Right, but there was parentheses first. So there was no addition subtraction outside of parentheses to take care of first, then the multiply divide. We did the exponents, then we did parentheses. And then we started over by getting rid of addition and subtraction here. So, simplifying radicals. You should be able to simplify and solve using radicals. Smith out!